Okay, hello my beautiful student, good evening to all of you. I can see here. Okay, so hello my dear, you taught very good chemistry. Thank you so much for your compliment. So yes, here we are going to discuss about the chapter solution that I already covered in the one short video for the KCET purpose. As you know, the Masterstroke series is going on, and if you really want top 1000 rank in KCET, please follow our series, and you can also enroll yourself in our ABHYAS KCET test series to get to know about your current situation. Current situation indicates like what is your current scenario in accordance to the knowledge of KCET basis. Okay, you can attempt 35 PYQs, 35 mock test, and you will get the PYQs of different chapters. So yes, without further delay, let's get started. Okay, so Masaq Ali Khan, I can see I saw all the practical experiment. It really benefit to me, and I score out of outs in my practicals. Okay, nice to see that. Very good, nice to know that you did really well in your practical examination. So I have seen that some of you people were really questioning about like how much or diluted or concentrated H2SO4 something like. So if you see the original equation of the Morse salt and KMnO4 original redox reaction, if you balance, okay, it comes up with a concentrated H2SO4. Okay, now you have to add acidic media, right? Now it depends upon what type of acid you are using, either concentrated or diluted. You have to add acid. Okay, so if you are adding concentrated acid, yes, definitely you have to add few drops, but whenever you are adding diluted, one test tube full. So I was using one test tube full, and I just slipped off tongue, I told it like diluted acid, concentrated acid, one test tube full. But at the meantime, please remember, you have to make the media acidic just to prevent the oxidation of iron. Okay, so that's the thing that I wanted to convey you people. And Sumit Kumar, one marker chemistry, one marker questions are there, 2, 3, 5 marker you will get by tomorrow itself. I'm working on it. So yeah, without further delay, let's get started. Here we are going to discuss typically on KCET PYQs on the solution chapter. So tomorrow you will get the kinetics, chemical kinetics chapter, and next I'm planning to give you some organic chapter. Then with chemical kinetics and organic chapter, I will come up with the next live KCET PYQs. Okay, let's proceed. Sorry. Okay, so here you can see the first question: which of the following methods of expressing concentration are unitless? So whenever it comes to the matter of unitless, if the numerator and the denominator, both the part, they are of same unit, then they can be get cancelled out and they can give you the unitless quantity, right? So if you just look for the mole fraction and mass percentage, okay, they are basically unitless quantity. Why? Because if you just look at the mole fraction, so mole fraction of A, let's say I'm having a compound A, mole fraction of A can be written as number of moles divided by total number of moles, right? So above also this is the unit of mole, below also it is the unit of mole, they can get cancelled out and you will get no unit at all, right? And if you just look for the mass percentage, so mass percentage also weight by weight means gram by gram or kg by kg, right? So unit will get cancelled out. So I guess you will understand that they will be having no unit at all. So let's proceed. Here you can see an aqueous solution of alcohol contains 11 gram of water and 414 gram of ethyl alcohol. So mole fraction of water we have to find out. So here you can see beta all the questions that are taken actually from the previous year questions of the KCET, the year is also mentioned. So please make sure that you are pursuing all the questions properly with a lot of patience, because in KCET questions can be repeated. Okay, so okay, I can get one, I can see one question. I solve this session question, how many marks I get? My dear, if you see, this is the way, like Masterstroke or any series, like whenever you are going through, these are the way to drive you to a better rank, right? So that your preparation gets well. Okay, so definitely if you do this question, you will get the idea what type of question you can face in your KCET examination. So that's what I can tell you, my dear. Okay, so if you know these things, you can get full common, that I can assure. Okay, rest depends upon you, what is your preparation, like that. So now you can see, next question, let's proceed. So first we will, mole fraction we have to calculate. So in order to find out the mole fraction, we have to find out the number of molecules at first, number of moles. So how I should find out? I have to first find out number of moles of water. Okay, and then I have to find out number of moles of alcohol. Okay, so here what they gave, 11 gram of water. So 11 gram divided by molecular weight of water, 18 gram per mole, right? Okay, so if you calculate this, it will come up to be 0.611, I guess. Okay, now for this case, if I calculate, here it is given as 414 gram, right? 414, and the molecular weight of ethanol is 46 gram. 46 gram per mole, right? So if you just calculate this thing, it will be almost equals to 9 mole. Okay, so now let's calculate the mole fraction of water. So if you calculate this, it will come up to be number of moles of water divided by total number of moles of water plus number of moles of alcohol. Okay, so let's proceed. 0.611 divided by 0.611 plus 9. Okay, so if you calculate, you will get 0.611 divided by 9.611, right? So from here, if I further calculate, we will get 0.06 something. Yes, option C is going to be the correct one. Okay, so today, yes, I will try with you people to solve this numerical problems without calculator. So if you feel that yes, some steps can be even more precise, even more accurate, you can just let me know in the comment section as well. Okay, yes, let's proceed further. So here you can see variation of solubility with the temperature T for a gas in liquid is shown by the following graphs, the correct representation. Okay, so solubility and temperature, in this one short video I told this properly, that if temperature is increased, solubility decrease. Okay, this is the relation, they are inversely proportional to each other. So in accordance to that, if you want to plot the graph, it will come something like this. You can see, if the temperature increases, solubility decreases. Okay, so that's gonna be the correct option. I guess it's clear to you. Let's proceed further. Here you can see solubility of gas in a liquid increases with pressure and temperature relation we have to find out. So basically, if you just look at the Henry's equation, pressure of gas is basically equals to kH into mole fraction of gas, right? So in accordance to that, if you see, pressure is directly proportional to solubility. I told you in that session, mole fraction actually represents the solubility, right? So from here you can see, means if you want to increase the solubility, then pressure will increase, right? And I told you solubility is inversely proportional to that of the temperature. If solubility decreases, temperature increases. So inversely proportional. So increase in P and decrease in temperature. Okay, I guess it's clear. Okay, let's proceed further. Let's proceed. Okay. I want you people to answer with me so that I can understand where you people actually existing right now. What is your current situation? Definitely it's gonna help you for the board preparation as well. like I got these questions as well. Why is this solution chapter again and again? First of all, this is your first chapter in your NCERT book, right? And this chapter holds highest priority in your board examination as well as in the KCET. Okay, so that's the reason I feel this is the easiest chapter. Why not to practice it more and more to give you proper grip and to do better? Okay, so yes, let's proceed. Here you can see the next question from the Henry's law. Okay, so if N2 gas is bubbled through water at 293 Kelvin, how many moles of N2 gas would be dissolved in 1 liter of water? Assume N2 exerts a partial pressure of 0.987 bar. Okay, KH is also given. Okay, so with me, you people also give it a try. So for this type of question, what I should do? You can see, we will at first calculate the mole fraction. So pressure of N2 is basically KH into mole fraction of N2. Everything is given. From here we can calculate the mole fraction. So mole fraction of N2 is going to be pressure of N2 divided by, N2 divided by KH, right? So pressure of N2 is given 0.987 bar divided by 76.48 kilobar. Okay, we will convert it to bar. So 76.48, 76480 bar. Okay, so now if you calculate 76, if I calculate, it will come something like 1.3. Yes, 1.3 into 10 power minus 5. It will come almost like that. Okay, let's proceed. Now number of moles of H2 if I calculate, then definitely 1 liter they have given. 1 liter means 1000 gram divided by 18 gram. 18 is the molecular weight. Right, from here I will get 55.5 mole. Right, so now from here I can directly calculate the mole fraction of N2, right? So let's just proceed here. So mole fraction of N2 will be equals to number of moles of N2 divided by number of moles of N2 plus number of moles of H2O. Now here what you can do, compared to that of the number of moles of water, number of moles of N2 is very less. Okay, very less. So we can avoid this term. Okay, so my equation will be something like mole fraction of N2 is basically equals to number of moles of N2 divided by number of moles of water. Okay, from here number of like mole fraction we can put from that 1.3 into 10 power minus 5. Number of moles of water is 55.55. That will be your number of moles of N2. Okay, so if you calculate, it will come almost like 13, right? .16 into 10 power minus 4. Okay, so your answer is going to be 2. Okay, I guess it's clear. Let's proceed. I guess you understood. From here we calculated at first the mole fraction. From the mole fraction we calculated the number of number of moles of water also we calculated. Just remember, for 1 liter number of moles is 55.5. Okay, now if you proceed with the mole fraction of N2, then you can just calculate number of moles of N2 you can just neglect, because very less moles of N2 will be there, so you can neglect that and you can just proceed with the calculation. You will end up with 7.16 into 10 power minus 4. I guess it's clear to you. Let's proceed. Okay, so here you can see Henry's law constant for the solubility of N2 gas in water at 298 Kelvin is given. Okay, the mole fraction of N2 in air is also given. The number of moles of N2 from air dissolved in 10 moles of water at 298 Kelvin. Okay, so let's proceed with the information that are given here. Okay, so what I can do is I can calculate the partial pressure of N2 at first. So partial pressure of N2 is basically total pressure into mole fraction of N2. Right? Now total pressure is given, you can see atmospheric pressure is given 5 atmosphere into mole fraction they are saying 0.8. Okay, if you do it, it will come as 4, right? Now you can just apply this mole fraction of N2 into KH, that is nothing but P of N2, that is Henry's law, right? So from here if I just put everything, 4 equals to mole fraction of N2 that I have to calculate into 1 into 10 power 5, 1 into 10 power 5. From here mole fraction of N2 will come 4 into 10 power minus 5, right? Now they are saying that number of moles of water, they are saying 10 moles. Okay, so what I have to do? Mole fraction of N2, I can also write number of moles of water divided by total number of moles, sorry, number of moles of N2. Number of moles of N2 divided by total number of moles, N2 plus number of moles of H2O, right? So from there, if I just continue calculating this, mole fraction of N2 will become, see here again H2O plus N2, we can avoid N2 because it is a very small quantity, right? So if I further proceed with the calculation, so number of moles of N2 divided by number of moles of H2O, okay? So mole fraction is something like 4 into 10 power minus 5 equals to number of moles of N2, and here number of moles of water is given as 10 moles, right? So like that. So from here number of moles of N2 I am getting 4 into 10 power minus 4. Okay, A is the correct option. Okay, I guess it's clear to you. Let's proceed further. Okay, choose the correct statement. Correct statement. Okay, KH value is same for a gas in any solution. No, KH value is different for different gases. Okay, next, higher the KH value, more the solubility. No, because you can see KH is inversely proportional to the mole fraction. So they are inversely proportional. So if you increase the KH value, then solubility will decrease, right? Next, KH value increases on increasing the temperature of the solution. Yes, that's true, because solubility is inversely proportional to temperature. Solubility is inversely proportional to that of the temperature. So now if you just put it here, then KH is directly proportional to the temperature. Okay, so that's gonna be the correct statement. Okay, so yes, let's proceed further. Here you can see the KH value, that is in kilobar, of argon, carbon dioxide, formaldehyde and methane are respectively given like this. Okay, the increasing order of the solubility, as you know, with more KH value solubility decreases. So you have to find out increasing order of the solubility, right? So here you can see, if you look for the third one, if you see for the third one, 1.67, that is the highest value of KH. Okay, this is the highest value of KH, so that is my 3. Okay, after that I'm just writing the order of KH. Okay, so after that it will come to be 4, right? After that it will come to be 4, 0.413, 0.413, that is your 4. Next, if you see, it's 2, right? That is 1.67. Wait, just made a mistake. Okay, wait. So if I want to find out the solubility order, we have to arrange the KH from lower to higher, right? So lower value if I put, that will be 1.83 into 10 power minus 5, that is of 3, right? Okay, next if I proceed, it will come to be 0.413. Next it will proceed 0.413. okay, that is of 4. Okay, next if I proceed, it is 1.67, 1.67, that is of 2. Okay, next if you proceed, it is 1. Okay, 1 value is how much? 40.3, 40.3. Okay, that is 1. So solubility order, if you just see, so here from here, this is the KH order, right? This is the KH order, KH is increasing. So if you just go opposite, that is the solubility order. Okay, the solubility order will be something like 3, then 4, then 2, then 1. Okay, so yes, A is the correct answer. Okay, so I guess it's clear to you. Let's proceed. Yes. Okay, so here we will proceed with the Raoult's law. Okay, so whenever Raoult's law it's coming, I guess you remember it is related to the two volatile liquid, right? So here you can see the vapor pressure of pure liquids A and B are 450 and 700 mm of Hg at 350 K respectively. Okay, if the total vapor pressure of the mixture is 600 mm, then composition of the mixture. Okay, so here how we should proceed? We will directly apply Raoult's law here. So PT means total pressure is basically equals to PA of 0 of XA plus PB of 0 to XP. Okay, now from here we can put the value here 600. This is given as 450 into XA plus PB0 is given as 700, and here in place of XB we can write 1 minus XA. If you just rearrange a little, it will come up to be something like 600 equals to 450 of XA plus 700 minus 700 of XA, right? So now if you just proceed, this will give you 100 if it comes there, and here you will get 250 of XA, right? Now if you just find out the XA, it will be 0.4. So with respect to that, if you find out the XB, it will be 1 minus 0.4, that is 0.6. Okay, so yes, your answer is going to be A. I guess it's clear. I can see Sagar Chopra is giving the answer. Very good. Let's proceed further. I guess this particular thing is clear to you. Let's proceed. Here you can see ideal and non-ideal solution. Okay, very important part. First question, you can see solution A contains acetone dissolved in chloroform. So whenever it comes to the matter of acetone and chloroform, acetone itself is having dipole interaction, right? Dipole-dipole interaction. And chloroform itself is having hydrogen bonding, intermolecular hydrogen bonding, right? So now what will happen if you are just putting one chloroform in acetone, right? Then what will happen? So chloroform and acetone can form the hydrogen bonding as well, right? So as a result of this, AB interaction will be more than that of AA and BB interaction as well, right? So initially as AB interaction is more, so you can tell that negative deviation will be shown here. Okay, and the next, B contains acetone dissolved in carbon disulfide. Here you can see it's a positive deviation of Raoult's law. Individual interaction is more than that of the AB interaction. Okay, so I guess it's clear to you. So your correct answer is going to be something negative, positive, option D. Okay, I can see Sagar, Manas, can you please recheck this answer? This going to be negative deviation and positive deviation respectively. Okay, because for the first case, acetone molecule and chloroform molecule, they can form the hydrogen bonding. Okay, like this. Okay, so this interaction is more prominent. AB interaction is more than that of the yes, I'm telling you, AB interaction is more than that of the individual interaction. Okay, so if you just see, Acetone molecule is having a dipole-dipole interaction. Chloroform is not having that type of interaction in between them. So AA and BB interaction is individually very weak, but whenever you are mixing them, then they are making hydrogen bonding, intermolecular hydrogen bonding. So AB interaction is more than that of the AA and BB interaction, right? So negative deviation, that is the condition for the negative deviation, right? And if you just see container B, it is carbon disulfide. Carbon disulfide, if you see, there is no dipole moment, and acetone there is dipole moment. Okay, so when they are mixed, AB interaction will be created, right? AB interaction will be created. AB interaction will be weaker than that of the AA and BB individual interaction, so positive. Okay, so I guess, okay, how to find the deviation? Okay, let me just tell you, my dear, whenever the compounds are given, na, check what type of interaction can be possible among them. Okay, let's say I'm having chloroform. Okay, so in chloroform, hardly there any kind of like interaction that is prominent. In acetone, you will be having dipole interaction, right? So now when they are mixed, I was talking about the individual, but when they are mixed, acetone and chloroform, then what will happen? In between two chloroform, acetone molecule will be placed. As a result of this, they will form nice intermolecular hydrogen bonding, right? So because of this intermolecular hydrogen bonding, AB interaction, means chloroform and acetone interaction, becomes more than that of individual chloroform and acetone interaction. That is the condition for the negative deviation, my dear. Okay, so I guess it's clear. Is this the continuation of Sankalp? No, Meta, this is a continuation of the Masterstroke. Okay, one lecture is uploaded on chemistry, that is solution. It's a continuation of it. Okay, just let me know if you understood this thing or not. Okay, so this is a condition of the negative deviation. So negative deviation, and later on, if you just see carbon disulfide and acetone, okay, so they are having weaker interaction. AB interactions are weaker, because if you see two acetone molecule, right, they are having nice dipole interaction. If you keep one carbon disulfide in between, so the interaction will be lost, right? So AB interaction is weaker. That is a positive deviation. Okay, so I guess it's clear to you. Yes. So yes, acetone shows positive deviation definitely, but you have to check with whom. Okay, acetone shows positive deviation with whom? That you have to check, na. Acetone with chloroform, acetone with ethanol, acetone with carbon disulfide. What is the another molecule that you have to check, right? So in accordance to that, if you check this, AB interaction is more here, so this is going to be the negative deviation. And next, if you just see carbon disulfide, there will be positive deviation. Okay, let's proceed further. Okay, a mixture of phenol and aniline. You can see here again that type of question comes. A mixture of phenol and aniline shows negative deviation. Here also you understand the reason. Negative deviation it shows, like this case, chloroform and acetone. Okay, what happens? One phenol molecule and one aniline molecule, they can form intermolecular hydrogen bonding like this, right? So this case also negative deviation, and this case also you can see negative deviation, right? Intermolecular hydrogen bonding, right? So that's the reason you can see intermolecular hydrogen bonding, that's gonna be the correct. Okay, how to find that? That's what, my dear, whenever by looking at the molecule you have to understand. My dear, if you just see acetone molecule, right? Acetone molecule is having dipole interaction, because you can see, I'm just showing you here, this is delta positive, this is delta negative, this is a dipole. So dipole-dipole interaction, right? But for this particular case, I'm having hydrogen. What type of interaction I can expect? Nothing that much, right? But whenever you are mixing them, then imagine what kind of interaction it can form, right? Here I'm having oxygen, here I'm having hydrogen. They can form intermolecular hydrogen bonding. That you have to find out, that you have to analyze. Okay, now again for the carbon disulfide, let me tell you, my dear, Carbon disulfide is quite similar to that of the carbon dioxide, right? So carbon disulfide is something like this. Is there any dipole? No dipole, no dipole-dipole interaction, no as such, no interaction. So now whenever you are putting this molecule in this, don't you think that the dipole-dipole interaction will be disturbed? Right? So AB interaction will be weaker, right? That is a positive deviation. Okay, I guess it's clear, Sagar. Please just, okay, thank you. Okay, let's proceed. Okay, here comes one, here we are entering into the colligative property. Please remember, my dear, this particular zone is super important for your board examination as well as for your KCET purpose, Comet K, whatever the examination you are going to give, even if you are preparing for the NEET, JEE, if you have given your JEE exam, then also I guess you must have understood this thing. So yes, let's proceed. First, from the relative lowering of vapor pressure. So, relative lowering of vapor pressure of a dilute solution of glucose dissolved in 1 kg of water is given. Okay, the molality of the solution you have to find out. Okay, let's do it. So, here you can see relative lowering can be represented by delta P by P naught. That is nothing but the mole fraction of solute, right? So, from here delta P by P naught is nothing but how much it's given? Delta P by P naught is given as 0.002, right? So from here I can write mole fraction of solute is basically 0.002 if I compare, right? So from here mole fraction of glucose, right? Number of moles of glucose divided by number of moles of water okay, plus number of moles of glucose, that's going to be 0.002, right? So now here you can see, here again I will do that approximation, okay, because 1 kg of water they told, 1 kg means 1000 grams, so 1000 gram divided by 18 means 55.55. With respect to that, number of moles of glucose is very less, so I can avoid it. Okay, so from here I can do this approximation. So number of moles of glucose will be 55.55 is basically equals to 0.002. So number of moles of glucose will become something 0. How much? 111, right? If I am doing any mistake, please let me know. Okay, I am not a human calculator. Okay, so number of moles I know. Now we will proceed with the molality calculation. So molality is basically number of moles present in 1 kg. So I can directly write 1 kg. This is mole. Okay, I don't have to do anything. By default it came mole per kg. So that is the answer. That's it. So option C is going to be the correct one. Okay, so I can see Tanmay Shetty. Ma'am, how much is it important to read NCERT textbook for boards, which I should read more organic? Okay, so my dear Tanmay, so basically NCERT is kind of a Bible to you. Bible in the sense is something that you must read. Okay, but once you are done with it, once you are done with your complete revision, I mean complete going through part, then just don't go back to that NCERT. Focus on the target zone. If you are a board student and if you are a KCET student, please focus on the target zone only, because in NCERT things are more elaborated. Okay, so yes, if you are a bio student or something, like you may say against me that ma'am is telling not to proceed with the NCERT. No, my dear, it's not like that. I am telling once you are done with NCERT, then don't go back to it. Okay, because you need to know more once you are going through the concept. Okay, once you are practicing, once you are revising, you need to clarify each and every concept. And in NCERT things are more elaborated. Sometimes we don't understand the things, we don't have a lot of patience to go through all the things, right? So better to take some good reference book, or to practice some numerical with respect to some mock test or something like that, I guess that will help you to boost up your memory. Not only memory, rather your practice as well. Okay, so yeah, let's proceed. Here you can see next question, vapor pressure of a solution containing 18 gram of glucose and 178.2 gram of water. Okay, let's see how to proceed. Again, what we will do, we will just simply find out the number of moles of glucose, number of moles of water. Okay, this I can do by 18 by 180. Okay, so I will get here 0.1 mole. Okay, now here 178.2 divided by 18 gram per mole. Please do the calculation before me. Okay, so if I do this, it will come something like 9 mole. Right, now mole fraction of water, if I calculate, it will come as number of moles of water divided by number of moles of glucose plus number of moles of water. So 9.9 divided by 9.9 plus 0.1. Okay, so this will give you 0.99. Right, now formula, pressure of the solution is basically equals to P naught into mole fraction of H2O. From here, P naught is something 760 torr, okay, into mole fraction of water. You can put it from there, 0.99. That will give you how much? Something close by 760 only. Only one answer is there. Okay, so 752.4. This type of approximation you can do actually, because this is 0.99 close by 1. So something you should get nearby 760. That is the only value. I didn't calculate. Okay, so yes, I guess you understood this. Let's proceed. Let's proceed. Which of the following pairs will show positive deviation from Raoult's law? Again, that type of question, positive deviation. So here, what do you have to find? What do you have to find? Sagar, give it a try. So you have to check where the after mixing A and B, the interaction is weaker, right? AB interaction is weaker. That you have to find out. Okay. So water and HCl. Okay, so if you just one by one we will see everything. Okay, so if you just look at that water and HCl, so water and HCl if you mix nicely, they will perform hydrogen bonding. So definitely AB interaction is strong, negative deviation, right? Next, benzene and methanol. Yes, if you just look at this particular case, benzene itself is having very nice van der Waal interaction, right? Surface area. And methanol, they are having hydrogen bonding. AA and BB interaction is super nice. But whenever you are mixing benzene and methanol, then those interaction will be broken, right? So for this case, it will show positive deviation. Okay, AB interaction is weak, right? Okay, we can say it directly without calculation. What we can say, my dear? I didn't get you. Yes. So next, water, we got our answer, but let's proceed with the next one as well. Water and HNO3, that will also show some hydrogen bonding, so it will also show negative deviation. And acetone chloroform, I already gave you the example. Okay, I guess it's clear. Very good, Sagar. Let's proceed. Okay, next we will proceed with the elevation in boiling point. Okay, so the question, you can see the rise in boiling point of a solution containing 1.8 gram of glucose in 100 gram of solvent is 0.1 degree Celsius. The molar elevation constant of the liquid, the molar elevation constant. Okay, let's proceed with the problem. So let's find out the number of moles of glucose. Okay, so 1.8 gram divided by 180 gram, because molecular weight of glucose is 180 gram, right? So from here I can get 0.01 mole, right? So from here what I can get, I can find out the molality. So molality is something, number of moles divided by the weight of solvent, right? So 0.01 mole divided by weight of solvent is how much? Okay, 100 gram of solvent. 100 gram of solvent, if I convert it into kg, then 0.1 kg, right? So if you calculate, it will come 0.1 mole per kg, right? Let's proceed. Now you know delta TB, okay? Delta TB is basically equals to kb into m. Okay, one more thing, you can multiply this thing with the Van't Hoff factor as well, I, okay? But here what I'm adding glucose, right? Okay, I'm adding glucose here. So glucose is a non-electrolyte, right? It will not dissociate. So I value will be 1. So if you multiply, and even if you don't multiply, it will give you the same result, okay? So kb into m, let's put the value here, and you have to find actually the kb, the nebuloscopic constant, right? So 0.1 Kelvin. Okay, degree Celsius is given, right? So degree Celsius, if you just convert it to Kelvin, if it will come as 0.1 Kelvin only, because the gapping is same, right? For degree Celsius and Kelvin as well, right? So equals to kb into 0.1 mole per kg. From here, if you find out kb will come as 0.1 Kelvin divided by 0.1 mole per kg. So I am getting 1 Kelvin kg per mole. Okay, 1 Kelvin kg per mole. Option D is going to be the correct one. I guess you understood. Okay. Sagar, previous question. Let's go back to the previous question once. Okay, for this case, my dear. Okay, benzene and methanol. I am telling you, my dear, understand this thing properly. Benzene, I have to show A and B interaction is weak, right? A and B interaction is weak. Then you can tell that positive deviation, okay? So in only benzene, if you see, only benzene, they are having van der Waals interaction. And only methanol, two methanol compound, they can have hydrogen bonding, no? Two methanol, hydrogen is also there, oxygen is also there. Individual compound, they are having hydrogen bonding, methanol, right? Now if you are mixing benzene and methanol, right? In between two methanol, one benzene is coming, right? So hydrogen bonding is getting disturbed. So AB interaction is not proper, hence positive deviation. I guess you understood. Okay, I can see Tanmay, ma'am, any tips to score 50 plus in KCET, like which chapters I should focus more? The solution chapter, I'm doing mistakes in problems, okay? Tanmay, my dear, definitely you can get 50 plus in KCET. So yes, you can follow this Masterstroke, that will be more than enough for you, because the full coverage, full chapter coverage along with the most probable problems are given over here, that will contain all the concepts, all the probable upcoming problems from the PYQs as well, okay? And tips are coming whenever you are just calculating, okay? So most of the cases I have seen people, they are proceeding with a proper way, but whenever it comes to the calculation, they are making the mistake. So definitely those particular case, I am thinking to bring one video to mention the tips and hacks to calculate, okay? Only the calculation part, like logarithm, okay, or something 10 power 2.59, this type of calculation, okay? Here only you need tips. Otherwise, I don't think that you will need that type of tips in this KCET examination and board, okay? So yeah, that's I guess. So mistakes, I guess you need more practice. Please identify from which zone you are making the mistakes, and that particular zone you keep practicing. Conceptual problem you do more, okay? Yes, Sagar, 1000 rank in KCET, yes, 0 to hero definitely. 0 to hero and Masterstroke is definitely, it's going to be more than enough. Please keep following us, and as we are taking the live session, as we are just coming up with the PYQs, as we are covering the one-shot videos you are getting constantly for the other subjects as well, please make sure that you are going through them and you are making a proper note out of it, because that's going to be your weapon just before your examination. Yes. Okay. So let's proceed. Okay. So here comes the next question. Okay, 180 gram of glucose is dissolved in 1 kg of water in a vessel. The temperature at which water boils at 1.013 bar is this. Okay, okay, Kb value is also given. So you have to find out the temperature at which the water will start to boil. Okay, let's proceed with the problem. So here again, glucose is added, right? So number of moles of glucose I have to find out. Okay, so that is 180 gram, I guess. Yes, 180 gram divided by 180 gram per mole, right? So from here I will get 1 mole. Okay, now calculate the molality. Molality is basically 1 mole, number of moles divided by the solvent, right? 1 kg. So from here you can find out 1 mole per kg. Okay, so now delta TB you have to find out. Simply just put it here, I into Kb into M. So I is definitely, it's a non-electrolyte glucose, it will not dissociate, so it's going to be 1 into 0.52 Kelvin kg mole inverse into 1 mole per kg. Okay, from here you can see every unit will be cancelled out and you will end up with 0.52 Kelvin. Okay, now you have to find out, we know delta TB is basically TB minus TB0, TB naught, whatever you want to say. From here I have to find out TB, right? So TB is basically equals to TB naught plus delta TB. So yes, if you just find it out, it will come up to be something like 373.15 plus 0.52. How much it will give you? It will give you 373.67. Okay, I guess it's clear to you. Yes, let's proceed. Okay, so here you can see solute X dimerizes in water to the extent 80%. 22.5 gram of X in 100 gram of water increases the boiling point 0.3 degrees Celsius. The molar mass of X you have to find out. Again, same type of problem, directly you can approach with the formula. Okay, but be careful about the calculation. As you can see that in the KCET level, whenever you have to calculate by yourself, the calculations are not that much hectic. Okay, so yes, be a human calculator and proceed. So okay, 80%. So as you can see, dimerization. So for dimerization, Ventov factor can be written as 1 minus 1 by n into alpha. Like that you can write. So for this case, it will be 1 minus. So as it is dimerized, that's why 1 by 2, right? Alpha is how much? Alpha value we can find out. Alpha, they are saying it is 80%. 80% means 80 by 100, right? 80 by 100. So you can write it as 0.8. I'm directly writing it here. Okay. 0.8. Okay, let's calculate the I value. So I equals to 1 minus, so from here I am getting 0.5 into 0.8. So from here I am getting 1 minus 0.4, that is 0.6. Okay, so now again delta TB formula, delta TB equals to I into Kb into M. Okay, so I have seen people asking me this type of question, that when to add this I and when not to add. Okay, whenever you will see that they are giving the hint that my particular solute will dimerize or it will ionize. Okay, that is a hint only. So then you have to add this I, you have to multiply this thing with I. Otherwise for non-electrolyte I is definitely there, but it will be 1. Okay, I is always there. Okay, just see if the hints are given that I value should be 1 or more than 1. Okay, that you have to find out just by looking at the question. So from here just put all the values. Delta TB equals to I into KB. Okay, molality let's break down. That is given weight by molecular weight into W1 into 1000. Right? M2 I have to find out. So M2 is basically equals to I into KB into W2 into 1000 divided by delta TB into W1. Okay, let's put the values. Here if you put I value is 0.6 into 0.52 into W2 is 2.5 into 1000 divided by delta TB is how much? 0.3, right? 0.3 into 100. Okay, so I want you people to do the calculation. Okay, here I am telling, yeah, it's an easy one though. You can just simply just divide and multiply. I am just directly telling you the answer. So if you proceed with the calculation, this will come up to be 26, almost equals to 26. Okay, so C is the correct answer. Yeah, I guess it's clear. Let's proceed, let's proceed. Yes. Okay, one big numerical. So I have seen you people get scared whenever you see this is the size of the numerical. But no, sometimes the bigger things are even innocents, right? So here you can see a sample of water is found to contain 5.8% weight by weight of AB. Okay. And XY2 that is 9.5%. Okay. Assuming 80% ionization of AB and 60% ionization of XY2. So the freezing point of the water sample you have to find out. Okay, KF values are given. So many informations are given. You can see I have a sample in which I am having AB and XY2. Okay, AB is there how much? 5.8%. Okay, and XY2 is how much? 9.5%. Okay, and how much ionization of AB? 80% and 60% for the XY2. Okay, so along with that we have to proceed. Let's see how we should do. Okay, so whenever it comes to the matter of ionization, then we can use this formula. I equals to 1 plus, it's going to be a lengthy one, that's why I'm starting here. I guess it's visible to you. 1 plus alpha into n minus 1, right? So now whenever it comes to the matter of AB, so AB if you just see, it will break down into A plus plus B minus, right? So n value is going to be 2 because 2 ions are coming out of it. So I of AB is something like 1 plus, see 80% ionization, right? 80% means 0.8, right? Alpha is going to be 0.8. 0.8 into 2 minus 1. Okay, if you calculate, it will be 1.8 I guess. Okay, let me know if I am wrong. Okay, now you can see next we will do for XY2. XY2 if it dissociates, it will give you X2 plus 2Y minus. Okay, so now from here also I am getting I value, sorry, n value equals to 3, right? So let's put it here again. I of XY2 is going to be 1 plus. So here how much dissociation? 60% dissociation, so 0.6, right? Into 3 minus 1. Okay, so if you calculate this, 1 plus 1.2, so it is going to be 2.2, right? Okay, So now mass of water, let's find out. Mass of water. Okay, so here you can see 5.8% of AB, means 5.8 gram of AB present, weight by weight, right? And here also you can see 9.5%, means 9.5 gram of XY2. Okay, so mass of water, definitely it should be 100 minus 5.8 plus 9.5. Okay, so if you calculate this, 5.8 plus 9.5 will give you minus 100 minus, okay, 84.7. Okay, 84.7 gram. If I convert it to kg, it will come to be 0.0847 kg. I guess up to this it's clear to you. Okay, so let's proceed further. Here you can see, now we are going to calculate the delta TF. So if you calculate the delta TF from here, so definitely that's going to be, I'm having two substance, so molality also you have to add the molality, right? So it will be KF into summation of I into M. Okay, so now for AB, let's calculate the molality. Let it be M1. Let's calculate the molality. So molality is going to be definitely given mass divided by molecular weight is also given 58.5 into weight of the solvent, that is 0.0847. Okay, so if you calculate this, okay, let me tell you by calculation, it will come something like 1.1706 mole per kg. Okay, now for XY2, let it be M2. I am calculating the molality, okay. So here also I will get 9.5 divided by 95 into 0.0847, okay. So if you do the calculation, you will get something 1.1806 mole per kg. Okay, so 2 molality I got. Now I will apply this formula. Okay, let's do it here. So now what I am going to do is delta TF is basically equals to, let's write the KF value 1.86 into, okay, so 2 different values are given, you can see 1.86, okay, so 1.8 into 1.1706 I into M, okay, 1.8 into this, okay, plus here I got the I value 2.2, so 2.2 into this value 1.1806. Okay, so now I'm not wasting time by calculating, simply I'm just telling you the value. If you calculate the entire thing, it will come up to be 8.75. Okay, it will come up to be 8.75. So this is my delta TF. Okay, so now what I will do, now you know TF I have to calculate. TF is nothing but TF naught minus delta TF. So TF naught is how much? 273 minus 8.75, right? This will give you 264.25 Kelvin. Okay, this is your answer. Okay, I guess this is clear to you. Let's proceed further. So this is from here, it is step number 1. You can proceed with the calculation of N. Then just put it in the equation of I, you will get the Van't Hoff factor. Then proceed with the molality calculation and then put it into this formula. Just add them. Okay. Yes, let's proceed further. Okay, so here you can see a non-volatile solute A tetramerizes, okay, in water to the extent of 80%. So 2.5 gram of A in 100 gram of water lowers the freezing point by 0.3 degrees Celsius. The molar mass of A we have to find out. Okay, it's an easy one. So again we have to apply this formula, I equals to 1 minus alpha plus alpha by n, right? Let's put the value of n. Alpha we know, alpha we know it's 80%, so 0.8. 1 minus 0.8 plus 0.8 divided by 4 because tetramerization, right? So from here 0.2 plus 0.2 will give you 0.4. From here delta TF, let's calculate I into KF into W2 into 1000 divided by M2 into W1. Okay, let's put delta TF, they are saying it is 0.3 equals to 0.4 into 1.86 into 25, weight is given 25 into 1000. M2 we have to find out, molecular weight into 100. Okay, so M2 if you calculate, if I just simplify this thing, this will be 0.4 into 1.86 into 25 divided by 0.3. So from here M2 will come up to be, if you just calculate, it will come up to be 62. Okay, your answer is 62 out of this. Okay, I guess it's clear to you. Yes, let's proceed further. Okay, so this is from the osmosis. Here you can see the swelling in feet and ankles of an aged person due to sitting continuously for a long hour during travel is reduced by soaking the feet in warm water. So this is because of osmosis. I have seen people marking it as edema. Edema is the name of the disease, name of the condition. But why this is happening? Because of osmosis. Okay, don't make mistakes here. Here you can see, next question, which of the following colligative properties can provide molar mass of proteins, polymers and colloids with greater precision? So that's going to be osmotic pressure, because whenever it comes to the large biomolecules, they are very much temperature sensitive. Okay, so if you are just heating, means elevation of boiling point, freezing point, those type of thing, whenever you are varying the temperature, they may break down, they may not sustain in those temperature variations. So that's the reason osmotic pressure is a better option. Even to calculate, the overall calculation is also easier than that of the other colligative properties. I guess it's clear. Let's proceed for the next one. If 3 gram of glucose is dissolved in 60 gram of water at 15 degrees Celsius, the osmotic pressure of the solution. Okay, that's a super easy question, I guess. So directly I'm going to apply the formula, you know, pi equals to CRT. So I can write, you know, N by V, RT. N I can write it as W by M, right? W by M into V, RT. Now just put the value, 3 divided by 180 into 0.06, right? Because 60 gram of water, they are saying, you know, the density of water is 1. Okay, 60 gram of water volume, you can write it as 0.06 liter. Okay, so from here into R value, let's put 0.0821 into 288. Okay, so let me just tell you, if you calculate, it will come up to be something 6.56 atmosphere. Yes, option A is the correct one. Okay, I guess it's clear to you. Just let me take a sip of water. Yeah, let's proceed. Which of the following pair of solution is isotonic in nature? Okay, so isotonic means osmotic pressure must be similar. So here if I just write this thing, pi equals to CRT. From here I can write, no, pi 1. From here I can, sorry, let me just mention the I as well. Okay, so from here I can write, from here I can write I1C1 equals to I2C2, because R and T, they are same, right? So we will check for each and every solution if these values are coming. Okay, first we will calculate for aluminium sulfate, right? So they are saying 0.001 molar Al2 SO4 whole thrice. Okay, so for this case, if I just find out I into C value, so that's going to be, if you just break down, what it will come, 2Al3 plus 3SO4 2 minus. How many ions? Total 5 ions, right? So 5 into 0.001. So it will come up to be 0.005. Okay, next we will proceed with BaCl2. 0.01 molar BaCl2. Okay, so let's put BaCl2, if you break down, Ba2 plus 2Cl minus. So I value, sorry, 2Cl 1 minus. Okay, so I value is going to be 2 plus 1, 3, right? So from here I into C, if I proceed with 3 into 0.01 equals to 0.03. So these two are not equal. So first option is cancelled. Okay. Next, again 0.01 BaCl2 we already did. Let's do 0.001 CaCl2. 0.001 CaCl2. So if you break it down, again Ca2 plus 2Cl minus. So I value is again coming 3. So if you do it, again I into C will come as 3 into 0.001 equals to 0.003. No values are matching. Fine. One more we are having. See, 0.01 BaCl2 we did already. Let's do NaCl. Okay, 0.015 NaCl. NaCl, if you break down, Na plus Cl minus. So I value is coming 2. So I into C, if you do 2 into 0.015, that will give you something 0.03. Yes, I got it, I guess. So these two are matching, right? Means option D is the correct one. They are isotonic to each other. I guess it's clear to you. Please make sure whenever any kind of solute, those are ionizable, if those are given, please make sure that you are taking the I value as well. Don't forget. Okay. Yeah, let's proceed. Okay. When the pure solvent diffuses out of solution through the semi-permeable membrane, then the process is called, it's very easy, it's basically osmosis, right? It's a very straightforward direct question. Okay, osmotic pressure of a solution can be increased by, okay, so you can see pi equals to CRT, right? So osmotic pressure can be increased by, pi is directly proportional to concentration. If you increase the concentration, pi will increase, osmotic pressure will increase. Another thing is temperature. So pi is directly proportional to temperature as well. If you increase the temperature, osmotic pressure will increase. So yes, this is the correct answer. Okay, increasing the temperature of the solution. I guess it's clear to you. Yes, let's proceed. Okay, 0.06% weight by volume aqueous solution of urea is isotonic. Isotonic means they are having same osmotic pressure. That we have to check one by one. Okay, first let me check the osmotic pressure of urea itself. So see, if I find out pi equals to CRT, right? If I find out the C concentration, if I find out the concentration of urea itself, then whatever the solution given in the option, they are having same concentration, they will be having same pi value because R and T is same, right? So let's find the concentration. So concentration of urea, that is how should I find? Mass by molecular weight into volume, right? Volume we will take in liter, fine. So mass is given how much? 0.06 gram, right? Divided by molecular weight is 60 gram into volume. Volume we can take it as 0.1 liter, right? So from here I can get 0.01 molar, right? Okay, now we will see one by one. First, option A. Option A is saying 0.6% glucose. Let's see, 0.6% glucose means 0.6 divided by molecular weight into 0.1, it will give you almost how much? 3, right? 0.033 molar. So they are not similar. Let's proceed with option B. Option B directly they told in molarity, so 0.1, that is also not matching. Again, see, option C I am not going further because already I got, this is quite similar to that of option D, right? So option D is going to be the correct one. Okay, so I guess it's clear to you. Okay, so whenever you will see the same concentration is coming, then you can tell that the pi value means osmotic pressure is similar. Okay, so I can see Vinayak, ma'am, you are beautiful. Oh, thank you so much. You are also very beautiful, my dear. Okay, so let's proceed. Okay, please stop doing it now. Let me just proceed with the teaching part and you also please concentrate on it. Let's see. Here you can see the next one. Isotonic solution. Isotonic solution means, again I am telling you, the same osmotic pressure. So option C is going to be the correct one. Okay, I guess it's clear to you. Let's proceed. This is related to the Van 't Hoff factor. Okay. Bache, I really want you to concentrate on your studies. Kaveri, hello Kaveri. Vinayak, please concentrate on your studies. Okay, it's a high time. If you don't practice now, then you will just miss what I missed. Like, you will miss in the sense, you will miss the time, you will miss the memories. Memories in the sense, you know, whenever you will be sitting with your pen and a paper in your examination hall, then you will feel that, okay, that time when ma'am was teaching, I was just doing the all shits. Okay, so please don't do this. Okay, high weightage chapter, my dear. High weightage chapter, definitely it's starting with the solution. Okay, the very high weightage chapter. After that, it will come electrochemistry, chemical kinetics, aldehydes and ketones. One by one, we will proceed. Don't worry. Okay, so yes, let's proceed. Okay, Van 't Hoff factor. So dimerization of the solute molecule in low dielectric constant solvent. Dimerization occurs because of the hydrogen bonding, my dear. Okay, so what happens if you just mix acetic acid? Okay, 2 unit of acetic acid, they get attached to each other because of the hydrogen bonding, intermolecular hydrogen bonding. Okay, for the 11th grade, my dear, definitely equilibrium chapter is going to be very important, and thermodynamics, chemical bonding. These 3 are very important chapter. Don't skip them. Basic concept, yes, important, but whatever I said, equilibrium chapter, never ever skip, and thermodynamics, proceed with them. Okay, so yes, for the 12th grade, you can proceed with the highest grade, highest weightage, you know, solution, then kinetics, then electrochemistry, aldehyde, ketones, these things. Okay, after that, for 11th grade, you can proceed with the equilibrium, very important one, thermodynamics. Okay, then you can proceed with the chemical bonding, like that. Okay, so let's proceed. Among the following 0.1 molar aqua solution, which one will exhibit the lowest boiling point of elevation? So see, the concentration is same, that is 0.1 molar, right? Now what you have to do, you have to find out the I, because all of them are, you know, electrolytes, right? They can dissociate. So once you will dissociate, you will get a different I value, because lowest boiling point, right? So delta TB, sorry, delta TB is I into KB into M. Everything is same. If you see the lower I value, then delta TB also will be low. Okay, so let's see for this case. If you just break down, last case I did the breakdown part, 2 Al3 plus 3 SO4 2 minus, so overall I will be 5. For this case, let me break it down here. Sorry, 2K plus SO4 2 minus plus SO4 2 minus. So here I value is coming 3. For NaCl, Na plus Cl minus, it's going to be 2. And AlCl3, Al3 plus 3Cl minus, overall it's going to be 4. So you can see lowest I value I'm getting for NaCl, so that is the correct answer. Okay. Okay, again I'm getting some spamming from Vinayak. Okay, ma'am, what's the secret behind your beauty? The love of my students, my dear. Okay, so I'm a big fan of Ankit sir. Okay, definitely I'm going to tell this thing to my colleague Ankit sir. Definitely I will convey this message. So yes, beta, don't do spamming and all here. So please focus on the study. It's high time at which you should actually proceed with your studies. Okay, I can see one comment, ma'am, I'm deciding to skip chemical kinetics and physical chemistry because it feels a little tough for me. All the other chapters are completed. Is it right to leave this chapter from now? No, beta, it's a very bad decision to skip chemical kinetics. Seriously, you are going to skip chemical kinetics? You should tell me once. Okay, we will come up with the chemical kinetics tomorrow, and then you take the decision, my dear. Okay, it's not an easy chapter. I mean, it's not a difficult chapter, my dear. It's going to be the easiest. Even dealing with the problems are also easiest. So, in your 12th chapter, whatever the most difficult numericals you can face, it is in the electrochemistry. So chemical kinetics is the easiest one in order to solve the numerical and other approaches as well. Okay, so please beta, don't skip. Okay, just let me teach you once. Let me just give me on chance to teach you, then you just take the decision. Okay, so yes, I want to speak to Ankit sir. Definitely you will speak to Ankit sir, don't worry. When he will come to live session, you can definitely speak. So yes, let's proceed. Okay, so which of the following aqueous solution should have the highest boiling point? Okay, so again you can see same type of problem we are getting. Just a minute. Okay, so highest boiling point for those particular cases, you can see molarity is same, right, for 1.0 molar. Okay, so for this case again I will just calculate the I value and I will get it. Okay, so here you can see I value is coming 2 because I am just breaking it down here, Na plus plus OH minus, so I value is 2 here. For Na2SO4, if you just break down, 2 Na plus plus SO4 2 minus, so how many? It's coming 3, right? For this case ammonium nitrate, NH4 plus plus NO3 minus. Okay, so this is coming 2. Okay, next you can see K plus plus NO3 minus, so that's going to be 2 as well. So you can see maximum value is here, so that's gonna be our correct answer. Okay, so now let's proceed. Okay, I can face some spamming out there from Vinayak. Okay, Vinayak, will you please stop doing it? It's a high time, please keep revising. Okay, it's very important. Let's proceed. Okay, here you can see next question. When an electrolyte is dissociated in solution, Van't Hoff factor. Okay, again I already told you this thing. Whenever a solution will dissociate, then you will get more number of ions, right? So I value will be more, right? So it will be more than 1. Option A is going to be the correct one. I guess it's clear. Let's proceed with the next question. I guess this is the last question. Yes, the Vedantu factor I accounts for, okay, this is basically extent of dissociation of the solute. Okay, dissociation, association, both actually. Okay, so here actually we covered the entire part of the solution. In the one short video we discussed some concept and some previous year question. There also few problems we discussed, and here in this particular session almost 10 years I tried to cover the most relevant PYQs. Last 5 years I completely covered. Okay, so please don't skip a single numerical out of it, because in KCET the concept as well as the PYQs, they keeps coming in the same way. Okay, so make sure you are doing all of them. And yes, all of you, okay, attention. Okay, fine. If one student wants to get attention, then fine, I'm here to give attention. Okay, so yes, my dear, all the best for your examination. Next class we will meet in your chemical kinetics session. So yes, if you are planning to skip this session, please wait until one day. Thank you so much. Bye. Have a very nice day. Thank you.